I'm not an ARC user myself, so I appreciate feedback. I've got only feedback from one user. So it works, I know that, but you can try. Extensions can also be installed directly from Git or the distro packages. Look at the README files that are part of the extensions, or fall back to distro packages. Extensions, that's what modprop is in Linux, is implemented as a simple command line flag. You specify -a for attach, and then you get a gnucap session with that extension loaded. Put that into a startup wrapper or load your plugins interactively. There's also an RC file, so if you have plugins that you always want to use, this is working. This is also being worked on to streamline the process. For example, gnucap make, what does it do? You hand code your plugin and you load it immediately into directly as the C code into gnucap, so you don't have to worry about compilation yourself. We have packages, the two that I mentioned, and there's a random variables package that implements random distributions in a more or less advanced way as compared to the SPICE random variables. We have this just-in-time compilation. We also have the gnucap Quark project, which tries to implement a drop-in replacement for Quarksator, which is the simulator engine behind the Quark project, or the default simulator engine. And a real-time audio processor, it's a toy project, but it works, it's fun. You can use your stereo to, or you can plug the real-time gnucap process to your stereo and real-time simulate audio filters if they are small enough or your computer is fast enough. And of course we have lots of model packs ready, which are probably from SPICE time, where gnucap was intended as primarily as a SPICE replacement, which it still is. And yeah, some of them have been ported, some are new work, and some are available as packages. If you are a packager, feel free, ask stupid questions. I will always help. I try to get it into Debian myself. Other distros I haven't looked at, so I will help with that. I appreciate packages, and I would like to see more of them. So what's the gnucap GDA project? There was a Google Summer of Code project by Savant Krishna, who has initiated a basic parsing for GDA schematics in gnucap, which probably was an idea of Al Davis. And a netlist and schematic should essentially be the same thing. And this will go a long way, and we have started it like this. And I wanted simulation from this and added some more conceptual algorithms to immediately simulate from GDA schematics without intermediate steps. This is now in the mainline as a plugin. So mainline now allows me to plug in my own sub-circuit implementation, which here takes care of netlist expansion from schematics. And I can use all these GDA schematic, gschem hierarchy, build my hierarchical netlist in a GDA schematic and directly run it in gnucap or load it. And I've got some quirks implemented. I call it default port values, which takes care of some connecting ports that are not representable in the symbols or not represented for other reasons. And yes, SPICE SDB, which you might know, didn't cut it for me, and so this happened. And yeah, the architecture is pretty simple. You have this hierarchical schematic. It uses symbols. Symbols have attributes. One is device, and on the gnucap side, the device specifies what device model will be used for that. and then you can either simulate or translate it one-to-one to a Verilog netlist. And you can interpret your results in the same namespace as your Verilog netlist or your schematic. There's no name mangling, there's no magic with global nets. It's all in place, and it's much easier to play with circuits and with simulation. And an example, this is the example I showed you last year in the same. We have a simple low-pass subcircuit, and you might know the GDA format. It has these coordinates in, and it has components like a resistor symbol, and the device attribute specifies what it is. And when I read that into gnucap and dump it in Verilog, I get this as an augmented Verilog netlist, which is all top-level components with coordinates. For example, there's a net, and it has its places, and places are attached to the wires, or so you can. Is this mouse available? Yes, you have these x and y coordinates, which are sort of a standard in Verilog. These are used to express what we need to get the full schematic information covered in this Verilog list. Yeah, what else? I have started a component library that supplements the GDA symbols. The GDA symbols all have default device attributes, and I want them to resolve in a useful way, so I started to implement gnucap components that just work as you would expect from what the symbols look like. And you can just change the device attribute and get anything behind that device that you might wish, like SPICE macro cells, which are often used, or even Verilog A models. And to get an easier grip on how to use that, I have last week I have included some examples that you can run directly from the installed package to get an idea of how easy it is intended to work. I have an operational amplifier. I scraped it off some old archive and added an analysis to that, so you can run it, you can see how it works. And similar frequency divider that has been communicated on the IRC channel by some other guy. He was asking how to do that with SPICE SDB, and I said, SPICE SDB, no, you don't need that. And now it's here as a live example, and as a comparator circuit that I found added to the repository. How does it look like in practice? You load that plugin again. This is the first line here. Oh, sorry. You then have the component libraries included. The commands for fetching schematics are a bit weird. They could be streamlined. That's the first approach to that. It simply says that there should be a device, my device, in the device namespace, and it is fetched from the schematic. And then I can switch to Verilog, do some other stuff, and even switch to SPICE, run a simulation, and get the results. This is a transcript of a gnucap session. You can type in these commands. You can as well dump it into a file and read it directly into gnucap. Anyone who knows Python knows that either way works, and it's the same here. And should be as simple as possible, and that was the intent. The next project is gnucap ADMS. This is a bit more involved. It is older, and it has been used for other purposes. I ported this to upstream gnucap, which, yeah, it was kind of a big deal because all the interfaces in gnucap UF, where it was originally written for, were a bit more broken than in the main project, and I needed some adaptations and accommodate for hacks that didn't really work. And so this is a pure plugin and doesn't need any changes in the main line. ADMS XML provides templates for ejecting simulatable component code for SPICE. So this is essentially Jacobian stamping code. I have completely rewritten that to more resemble the model gen, which is the old gnucap model compiler architecture. That's why sources, I implemented controlled sources, so it's based on netlists of controlled components, and the real code is written in C++ and is not generated. The only part that's generated is some arithmetic expressions and some topology stuff, which need to be worked on, but we have now a netlist of controlled components. And of course it's Band-Aid, but works. So you can see that the transient simulation in gnucap works better than the others by using these models. Don't expect that they are particularly fast. The optimization has not been implemented. Thank you. So we have voltage sources and current probes, unlike the SPICE templates for the open SPICE templates. I don't know what in-house tools can do with ADMS. So what we can do is these voltage sources and probes, which were missing, we can instantiate sub-circuit components into compiled netlists, which sort of makes use of the dynamic loader and the expansion algorithm that we have in gnucap. We have some more linear operators than the ADMS templates have, and it looks like it did end, but I am optimistic that we can recycle huge parts of that to re-implement the ADMS XML part and reuse, for example, our sources, and to get a grip on optimization on top of this architecture. And whether we write an own model gen inspired tool or we use Icarus, well, it depends on who does it or who has experience with these compilers. And anyway, this architecture I think works and should be continued or being worked on. And maybe that might be a way to compile and distribute IP blocks. People have secrets. I think it's bad, but we need to respect that. And if it's possible to compile these secrets into binary blobs that can be distributed for gnucap in some way, would be beneficial for everything, for everyone, because they get the simulation and we get models, and we don't have to use size macro cells. Let's see what happens. And of course, we need full ADMS support. Yeah, we are working on it. Maybe next year. In practice, we have this schematic again. Here I have, yeah, this is, I had the unit tests in the BSIM 6 package, has a 17 inverter ring oscillator. I put it into a schematic, and then you again see this batch file, and you run it, and of course you can AHDL include. You might know this command. I called it like this to ring a bell. This model, include your SPICE style or Verilog style param sets that they ship, and run a ring oscillator, get some result that you can immediately GNU plot or visualize any way you wish. And that's how easy it has become. Yeah, the outlook. We need some cooperation, of course. There's work in progress on Quack's end. I hope at the KiCad end there will be some schematic exchange someday, so we can have this, maybe this Verilog schematic bridge or some other format that we can parse. I don't know. It might make sense to have that. And I hope for packages always. And I have a lot of crap in the UF repository that is really worthwhile and clever. Some other things aren't, but the point is it's possible to port all this into plugins, and I will keep working on that. And that's it. Thank you for listening. Questions?
Boring one. You mentioned binary blobs. Technically, is that going to be compatible from a licensing point of view?
The question is whether binary blobs are in license terms applicable to the project. Yes, they are, because we don't link to the kernel. We just load the plugins. So what we currently have is a spice wrapper. You can come with your spice 2 or 3 binary blobs, wrap them into a gnucap class, link it to that. The class is licensed, whatever you want to do with it license. So you get this binary blob wrapped for free and with every freedoms and without any license restrictions, and can do whatever you wish with that binary blob.
The GPL applies to distribution, and when you, in some cases, okay.
There's another answer from Alf to this question.
Oh no, GPL applies to distribution, not use, and so the bit about binary blobs, well, it's not our favorite thing, but sometimes the models come that way and we're stuck with it. And these binary blobs are not binary blobs written for gnucap. They're binary blobs that were written for something else, possibly even ngSpice. And the point is that, well, here's a device model. We want to use it. I don't really know where it came from, but somehow it's here. And so by adding an extra layer, it puts it in a position where we can use this binary blob that was intended for something else, and map it to the gnucap interface. Make sense?
Yeah. Thank you.
Okay.
Thank you.